Okay, in today's video we're going to actually be looking at a new topic which is Gaussian elimination. Okay, but it's on the basis of matrices. Now we haven't seen matrices yet, but don't worry, we're going to look at that more in depth in Unit 3. But we're going to start off by just focusing on Gaussian elimination and what that is. Okay, so the main thing to know about matrices are it's just a way we can organise a row of numbers. Okay, and it's got to be plural because obviously one number would just be one number, wouldn't be a matrix at that point. Okay, and what we're going to do is we're going to be thinking about the rows and columns and how to solve to get Gaussian elimination. Okay, that is an example, just a quick one to show you, of a 3 by 6 matrix. Okay, because there's 3 rows with 6 columns. Okay, and that's going to be more for a later part of the course. All right, so pause this video, copy that down just now. Right, okay, so what we're going to do is we're going to solve these equations here. Okay, so a bit like simultaneous equation, this is what Gaussian elimination is. We are going to use matrices to solve and get values for x, y, and z that would satisfy these 3 equations here. Okay, what we do is we get our coefficients of the variables, our x, y, and z for all 3 equations, and we're going to put that into a matrix here. Okay, row of numbers. You'll see that's what the coefficients would be. And then we've also got the solutions that can be written as a matrix, which probably looks more like a vector from higher. Okay, you've probably seen vectors written like that from higher. And a vector is a type of matrix. Okay, but the main thing is, again, pause this video so you can copy this down. But the main thing is, that's how we're going to set them up. Okay, we're going to have our coefficients on the left with our solution on the right, and we're going to do some operations to try and solve these here. Okay, and again, the row operations are very similar to what they were at Gaussian elimination. Okay, and our job is to try and get it, which I'll show you, into upper triangular form, which I'll show you below in a second. Okay, so again, pause this just to copy that down. Right, the row operations. So the 3 ways that a matrix can be manipulated to solve a system of equations are called elementary row operations. Okay, so these are the rules that we must abide by. So the one thing we can do is we can interchange 2 rows. So if we're not happy with how the rows are set up, we can swap them about. Okay, but we must keep all the rows the same, just swap them about in order. We can multiply one row by a non-zero constant, okay, like what we've done at simultaneous equations. And lastly, how we're going to edit this and how we're going to create an upper triangular form is we can add one row to another row by a multiple operator, okay? And obviously if it's a negative multiple, then it's the same as doing a subtraction, okay? So that's what we're going to focus on here, okay? So those are the rows operations that we must always abide by. So again, you can pause that and copy. So here, upper triangular form, you can see here, you might want to highlight this. I have now got zeros in my bottom corner, okay? And that's how we want to solve these, okay? We want to end up with zeros in this bottom corner here so that we can then solve. And I'll show you an example how that would then give us the answer. But that's the aim, okay? Our aim is to use those operations to create zeros in there, okay? Anything else we're fine with. It has to be down there to help us out, okay? Once we do that, we then have enough information to solve our original system of equations. Okay, so we're actually going to look at an example now. Okay, and we're going to look at how we're going to solve it. So we'll start off with the same question that we actually began with. Okay, the same system of equations. Okay, so example 1, we're going to solve using Gaussian elimination. X plus 3y plus 2z equals 8. And we're going to have x plus 4y plus z equals 13. And we've got 2 x's plus 9y minus 3 z's equals 35. Okay, so that's what we've got as our equations. We want to solve to get an x, y, and z such that it would satisfy all 3 of those equations there. Okay, what we're going to do is we're going to give us our matrix, okay, with our coefficients and our solution. So our first row was 1x, 3y's, and 2z's. Okay, put a wee dash line, okay, to show that that's our coefficients and our solution is going to be after, and it's going to be an 8. It could be a bold line to be fair, but I like a dash line, okay. Our second equation, that was 1x with 4y's and 1z, and that gave me a solution of 13. And lastly, we had 2x's, 9y's, and minus 3 lots of z is 35. Okay, so I've got that there. Okay, so that's my matrix set up. Now, again, we want to get zeros in this bottom corner. You're not going to do it all in one step, okay? What we'll do is we'll do it just one bit at a time, okay, to show you. You might be able to include 2 steps later on once you get more used to it, okay? But just initially, what we'll do is we'll just take it one bit at a time. So what we'll do firstly is we will write down what we're going to do at the side, okay, so that we keep an eye on it. It's a good way to just make sure you're keeping up to date with what the steps are going to be, okay? So, I want to try and get a 0, first of all, in this very bottom left-hand corner, okay? So what I'm going to do is I'm going to focus on row 3, okay? So how am I going to get a 0 in that bottom corner? Well, I can do row 3, okay? And I can take away 2 lots of row 1 from it, okay? Would we see that that would give me a 0 in this bottom corner, yeah? If I'd done row 3, which is 2 here, take away 2 lots of that 1, 2 take away 2 lots of 1 would give me a 0 there, okay? And that's what I want to achieve. So that's going to be the first thing I'm going to do, okay? So at the minute, row 3 is the only thing changing. So I've got 1, 3, 2, 8, 1, 4, 1, 13. And now I'm needing to deal with my rule, okay? So row 3, well, 2 take away 2 lots of 1 is 0. Okay, that's good. That's what I wanted. I wanted a 0 there. Okay. Right, I've got 9. Take away 2 lots of 3. Okay, because I've got to keep the coefficients in line. Okay, so 9 take away 2 lots of 3. 9 take away 2 lots of 3 is 9 take away 6, which would give me 3. Okay. I've got negative 3. Take away 2 lots of 2. Okay, so negative 3 take away 2 lots of 2 is negative 3 take away 4, which is negative 7. And then 35 take away 2 lots of 8. Okay, 2 lots of 8 is 16. So 35 take away 2 lots of 16. 2 lots of 8, which is 16, gives me 19. I believe. Okay, hopefully I've done that correct. Okay, so you can see I've now got a 0 in my bottom corner. Okay, deal. Okay, I've done the good thing. Right, the next easiest one to deal with is, well, I want to get a 0 where the 1 is currently, okay, where the sort of 1 star is there and where this 3 is. The easiest one to deal with is the one above it now. Okay, so let's now think about how we can change that first entry in row 2. So I could just do row 2, take away row 1, couldn't I? Yeah, that would cancel that 0. Yeah, that would cancel that 1 off and give me 0. Okay, so 1 doesn't change. That's 8. 1's now going to change. 3's not going to change though, so I can write 3 in. Okay, let's now change this. Okay, so row 2 take away row 1, so 1 take away 1 is 0. 4 take away 3 is 1. 1 take away 2 is negative 1. 13 take away 8 is 5. So my row 2 now looks like that there. Okay. Okay, so now I want to try and get that 3 here that I'm going to start as a 0 as well. Okay, so I now want to try and do that. So I now need to fix row 3. And this is where I've got to be careful with how I'm going to do this. So, I don't want to involve row 1 in my calculation now. Okay, the reason being is I know my first entry at the minute for row 3 is already a 0. So if I add or take away something from row 1 to it, it's going to change that back into something different. Okay, then I've undone all the good work I want to do. So I'm actually going to use row 2 this time because I know that's already a 0 there too, and the zeros will just keep each other as zeros. Okay, so I'm actually going to do row 3. I still want to make that a 0, so in order to do that, I'm going to have to take away 3 lots of row 1. Okay. Row 2. Thank you, row 2. Okay. So row 2, row 1, sorry, doesn't change. Row 2 is not changing, but row 3 is, okay? Well, the good thing is row 3 take away 3 lots of row 2, 0 take away 3 lots of 0, it's still 0. So I've still got that 0, that's fine. 3 take away 3 lots of 1, well, that's 0, that's good, that's what I wanted in there. Negative 7, take away 3 lots of negative 1. Okay, so just be careful with negatives, but you should get negative 4 there. Okay, and 19 take away 3 lots of 5, that's 19 take away 5, take away 15, which is 4. So I've now got that there, and I've now got my upper triangular form. So I've achieved the zeros in this spot there. Okay, done. Okay, well, not done this question, but that's me finished changing my matrix a bit. Okay, now I'm in a position. So looking at now row 3, it's telling me that negative 4 lots of z, because that's what that last column was, okay, equals 4. Okay, therefore z would have to be negative 1. Okay, so I found my value of z. Okay, so if I now go to, if I put this back up slightly, there we are. If I now go to row 2 now, okay, you always do it from the bottom, that's telling me that I've got a y minus a z equals 5. Okay, that means that y take away negative 1 equals 5. Okay, which will then lead me to solving that y is 4. Okay, so should get y is 4 there. Are you okay with that one? Yeah. Okay. And now lastly, I want to now get my value of x. I need to use row 3, so from, not row 3, row 1. Well, that had 1x plus 3y's plus 2z's. That equaled 8. Okay. Well, I know that's now x plus 3 lots of 4 plus 2 lots of minus 1 equals 8. Okay. And if you solve that, would lead you to an answer of x equals minus 2. Okay. So the nicest thing to do is once you get your solutions is write them all in a box. Okay. So x is negative 2, y is 4, and z was minus 1. Okay. Now those are the solutions, but the way you could check, okay, you could put those numbers that you've got into all 3 of your equations that you started off with, and they should all work. Okay, you'd be able to show that they work, therefore you know you found the right solution. So there's a bit of a check, like how you can check simultaneous equations, for example. That's the first example. How do we find that? Cool. Okay, we'll look at a second one, all right, and then we will have a go at this one. Okay, so. Oh, just lost half my page. Let's go back up a bit. There we are. So, example 2. Okay, we're now going to solve x plus y plus 3z. That's going to give me an answer of 15. Second equation is 2x plus 3y plus z. That's going to give me an answer of 17. And 5x plus 2y plus 2z equals 30. Okay, so that's what we're going to look to solve in this question here. Okay, so we have our matrix. So we've got 1x, 1y, 3z's, and that would give me 15 on the top row. 2x's, 3y's, 1z, gives me 17. 5x's, 2y's, 2z's, and that equals 30. Okay, so that's what I'm wanting to solve now. Okay, so again, system's the same. We want to try and get our zeros in the bottom corner. Oh my goodness, we've lost the question totally now. There we are. So I want to try and achieve a zero. The first one I want to try and achieve a zero at is where this 5 is. Okay, so I'm going to deal with that there. Okay, so we're going to do row 3. Well, there's loads of ways I could get 5 off here, okay, but the easiest way is just to take 5 lots of row 1 off. Okay, that'd be the easiest way. Okay, so it's be row 3, take away 5 lots of row 1. Okay, so that's how I'm going to do that there. Okay, so that's 1, 1, 3, 15, 2, 3, 1, 17. So those two rows didn't change. Right, let's take 5 rows of row 1 off row 3. Okay, so 5 take away 5 lots of 1 is 0. Good, that's what I was hoping. 2 take away 5 lots of 1. That's 2 take away 5, which is minus 3. 2 take away 5 lots of 3, or 5 lots of 3 are 15. 2 take away 15 is minus 13. And 30 take away 5 lots of 15. 5 lots of 15 are 75, I think. So 30 take away 75 is minus 45. Okay? But the main thing is I managed to get a 0 in that bottom corner there. Okay? So the next 0 place I want to try and get is where the 2 is in the row 2. So let's now work out this one. So row 2 is going to be row 2 take away 2 lots of row 1. More space. 2 lots of row 1. So 2 take away 1, row 1 stays the same first of all, so let's put that in. And so there's row 3, that's not going to change. Okay, 2 take away 2 lots of row 1 is 0. 3 take away 2 lots of 1 is 3 take away 2, which is 1. 1 take away 2 lots of 3 is 1 take away 6, which is negative 5. And 17 take away 2 lots of 15, 2 lots of 15 are 30, 17 take away 30 is minus 13. Okay, so we should now have a matrix that looks like that. Okay. Right, so lastly I want to get a 0 where this minus 3 is. Now again, we don't want to touch row 3 with row 1 because that might interfere with the first 0, so we're going to keep that just hitting off row 2. Okay. So I need to think of how to do this. So if I want to get row 3 in that start position to become a 0, well, I don't want to take away 3 lots of row 2, I want to add 3 lots of row 2. That way it will become 0 because it's already minus in that position. Okay, so that's what I want to achieve here. So again, row 1 doesn't change. Row 2 doesn't change now, so that's still 1, negative 5 and 13, whereas negative 13 was 0 at the front. And, right, okay, well, good thing is that 0 at the bottom corner will stay because it just bounces off another 0. Negative 3 plus 3 lots of 1, well that is 0, that's good, that's what we wanted. Negative 13 plus 3 lots of 5, negative 5, well 3 lots of negative 5 is negative 15, so negative 13 plus negative 15 is negative 28. Okay. Negative 45 plus 3 lots of 13, so 3 lots of 13 are negative 13, so it's negative 39. Negative 45 with negative 30 is negative 84.
Yeah.
Okay, big numbers. Okay, well, actually small numbers, negatives, but okay. But now we can solve, okay? Because I now have got my zeros in my upper triangular form. I had to stop doing that. Lost my page here. Right, okay. So, from row 3, and this is where you're hoping this works, but you could easily expect fractions to happen here. Okay, easily. Okay, so don't always assume your answer will be always whole numbers. Okay, so from row 3, okay, well I've got negative 28 lots of z, that equals negative 84. Thankfully, okay, that does give us z equals 3. Okay, 28 fits in 84 3 times. Okay, from row 2, well we've got a y minus 5z equals minus 13. So that's y take away 5 lots of 3 equals negative 13. Solving that, y would equal 2. Okay, y is 2. And lastly, from row 1, we have got an x plus y plus 3 lots of z equals 15. So that means that you've got an x plus 2 plus 3 lots of 3 equals 15. solving that would give you x equals 4. Okay, so again, pop your solutions in a box. Makes it easier for the marker. So x is 4, y was 2, and z was 3. Okay with that one? Okay, perfect.